Buddy. Wanted to give you a head start on what we're working on this week. Um, talking about Venn diagrams, set operations, and in case you're wondering what that word set means when we talk about that, a set in math we're talking about a collection of numbers or a collection of values. Okay, so a set, you can picture a set like this. Oops. Okay, that's a set of numbers, and we use those curly braces to show a set. So when we're talking about sets of numbers, it's often helpful to have a Venn diagram. Maybe if there's a lot of different sets that intersect, if there's like three or more sets that intersect, they cross with each other, we can find out how many values are where they cross, how many values are outside where they cross. You can see a good example of this in the discussion board this week. So check out the discussion board, the instructions there. You'll see a good example of a Venn diagram in action. So let's check out Newton, what we have to do this week. So this topic, representing sets with Venn diagrams. So you get two sets, set A and set B. Okay, A might be the number of people that have cell phones. B might be the number of people that drive their own car. And remember, U just represents everyone in your sample, everyone that you're investigating. So, like, if you ask people, do you have a cell phone? Do you drive your own car? The union would be everyone, including the people that don't have a cell phone and don't have a car. Sorry, and I know there's a lot of terminology coming at us, but just remember, A stands for one group of people, B stands for a different group of people. Sometimes these two groups overlap because, in my example, they both have a cell phone, they both have a car. So we're supposed to say, what is the complement of B? And the complement is a pretty easy idea once you get used to it. Okay, the complement just means everything but a certain characteristic. So if we go back to that analogy where B represents the people that had cars, the complement of B means people that did not have cars. So for this question, I'm going to count out 3 and 7. That makes 10 people. 3 plus 7 plus 1 plus 6 plus 9 plus 11. See how I'm just adding the values that are outside the set of B? This 11's outside, the 9's outside. If you add those up, that'll give you the complement. Oh, sorry, and it's the values here. So the complement, there's a 3. So looks like these options don't have a 3 in it, so I'm not going to use those, okay? There's a 3 in the complement set. There should be a 7 in the complement set, so these two are good, okay? There should be a 1 in the complement set. This one's missing a 1, so this is the correct answer. Okay, and then just one last time. The complement of B means everything except for B. So that's why I'm choosing that. Let's make sure I got it right, though. Okay, and then let me see if there's a different type here. Yeah, we'll do one more, and then I'll show you another one. Just following Venn diagrams correctly represent sets. A is 1, 2, 3, 7. B is 4, 5. C is 6, 7, 8, 9. Okay, so look for some overlaps in these sets. Okay, maybe these sets represent the number of televisions in a house. Okay, in my house, it's this one, but maybe set A as represented people from like one side of town. B is people from another side of town. This side of town's the C people have lots of televisions in their houses. Okay, so to figure out which one is the correct representation, look to see if they have the same numbers in them. They should cross at those places. Look, set A has 7. C has 7. So we should see a 7 in between the circles A and C. So I'm going to rule this answer out because there's no 7 in between. The 7 is in between B and A, which isn't correct. So this one is possible, okay? Look, A and C both share a 7 because the green circle and the red circle have a 7 in it, but set B doesn't have 7, so this answer's out. Okay, here, this one looks good based on that 7 that we were talking about. We said just A and C share the number 7, so that part's checked off. So let's go check everything else. Set B is supposed to have 4 and 5, and that's not in any of the other sets. So that's good. B has 4 and 5. That checks out. A is supposed to have 1, 2, 3, and that's 7 that we were talking about. So that's good. Oops, sorry. We're down here and we're looking at the third option. 1, 2, and 3, that's good. The 7's there, the 4 and 5's there. 6, 8, and 9, so this is going to be our correct answer. Okay, so look for those overlaps. That's the key. If they're supposed to overlap, you got to make sure it's represented in the set. Okay. So it shows sets Q, I, and universal set R. I think they're talking about imaginary, rational, and real numbers. Yeah, they are. Yep. So just a little bit of math vocabulary for you. Q stands for, it's usually like shorthand for the set of rational numbers. Let me just double check. Yep. Okay. Just wanted to make sure. I remember it from college and it came up a lot. I should be sure on that. But yeah, Q is rational numbers, which you've probably seen in a previous math course. It just means numbers that you could write as a fraction of two integers. Okay. So this is rational because they're integers in a fraction. Okay, pi is irrational. That's why it's not in that set. Because, oh, no, I must stand for irrational. Sorry. Q is rational, I is irrational. That makes more sense because imaginary numbers have I a lowercase I next to them. So yeah, these are irrational because pi you can't write as a fraction. Okay, as a fraction of two integers. Square root of 2 can't write as a fraction. E you cannot. Okay, so we're supposed to check all that apply. So that R in the set of real numbers, so that R is on the outside. That means both these types are real numbers. So R and Q are disjoint sets. Okay, disjoint means that they don't cross with each other. Look, the real numbers is everything here. These are both real numbers, so they do cross. That's not a true statement. Okay, so remember, disjoint means that they don't cross. Q and I, the rational and the irrational sets are disjoint. That is true because they don't cross with one another. They don't share numbers. The set of real numbers, the set of real numbers and the irrational numbers are disjoint sets. That would be true if the real numbers, which is this entire box, never crosses with the rational numbers, and that's not. So they do cross. That's not a true statement. And then Q and R, the rational and real numbers, are a complement of the imaginary numbers. Okay, so look at the imaginary numbers. The complement is everything except this circle. So that's a true statement, right? Because everything outside that circle is a real number and a real number and a rational number. Okay, but I don't think we can check this one because it's saying all rational numbers, and rational numbers include irrational numbers. Okay, so rational numbers includes this. It doesn't. If you say rational numbers is a complement, you haven't said something true because it encompasses this circle. So I think we got the only thing. Okay, just one statement is true there. Okay, so you guys can handle that one. Let's check out another topic. So set relationships. This little symbol here means intersection. Okay, that means find where A intersects with B. Or in other words, find out where the set of A shares numbers with the set of B. Okay, so I'm looking at set A, 1, 2, 3, 4, 5. Set B, 6, 7, 8, 9. There's no intersection. Okay, they don't cross with each other. They don't share the same values. So we have to use this symbol here to show the null set. Okay, it means that they do not cross. Okay, this symbol here, the U, means union. That means you're supposed to take this set and include whatever the other set is with it. So take set X and add whatever it doesn't have from set Y to make one big happy family, okay? So the set notation here should be A, B, C, and then I think I remember that we're supposed to put the null set in here too, but it doesn't look like it's available. Let's see if it accepts this, okay? Because remember, this symbol stands for the null set. That means nothing. Yeah, okay, it accepts that. Okay, so P is a set of integers that are multiples of 3 between 1 and 20. So we could list those out real quick. right? Multiples of 3. So we got 3, 6, 9, 12, 15, 18. That's the set P, okay? A little P up there so I know. Q is a set of even natural numbers up to 15. So even natural numbers meaning kind of like the counting numbers. 1, 2, 3, 4, 5, okay? So 2, 4, 6, 8, 10, 12, and then I think it said up to 15. So that's set Q, okay? There's P and there's Q. Which of the following sets is not a subset of the union of P and Q? So we got to figure out what the P union Q set is. Okay, remember union means you take all the numbers from P and include all the numbers that weren't in set P that are coming from set Q. So for P and P union Q, we've got 2, 3, 4, 6, 8, 9. You can see what I'm doing is I'm taking all the different numbers from here and making that be the set of P union Q. Let me see if I can make this easier to see. That doesn't help, does it? Still covers it up. So we got 2, 3, 4, 6, 8, 9, 10, 12, 14, and then multiples of 3, right? 3, 6, 9, 12, 15. So 15. And then we set up to 20. So 18. Let me see if I missed it. 3, 6, 9, 12. I think we got them all. Okay, I took all the numbers from P and all the numbers from Q and made them one big happy family because that's what union does. Okay. All right, so now we can answer the question. Which of the following sets is not a subset of the union P and Q? So a subset, remember, is just subset just means a smaller portion of the bigger set. Okay. So 3, 5, 6, and 12, for example. 3 is a member of P union Q. 5 is not a member of P union Q, so that is not a subset. Okay, let's go on to the next one. 6 is a member of P union Q. 12 is a member, so this one looks good. Let's just check the other ones. 3, 6, 12. Oh, we're supposed to pick the one that's not. We already found it, okay? Because 5 wasn't one of those values. 3, 6, 12, those are all members of P union Q. 3, 6, 12, 15, those are all members of P union Q. Okay, let me do one more, then we'll pause this video and make another one. So let A be the set of integers that are multiples of 3 between 1 and 15, and B be the set of even natural numbers up to including 20. This is 3, 6, 9, 12. Yeah, we got to make a new set here. Okay. Delete the P too. Okay, so set A is all the multiples of 3 between 1 and 15. So 3, 6, 9, 12, 15. There's the set A. And B is a set of even natural numbers up to including 20. So even natural numbers. We've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay. So we're supposed to find A intersect B. So where set A crosses with set B. A has a 3, B doesn't. So that's not a place where they cross. A has a 6, B has a 6. So that's a place where they cross. A has a 9, but B does not. A has a 12, and so does B. So that's an intersection. And then A has 15, B does not. So it looks like we just have 2 places where they cross, 6 and 12. Okay, so hopefully it gets you started on those first 2. Let me see what I can do about helping you with the other problems from Newton this week, okay?